Okay, here's hopefully a copy of the presentation. And even though it's in the presentation, I'm going to put the sign in the chat bar also.
It says we need permission to access it. It says access denied for the link.
Okay, thanks. I'll go and try to fix that right now. Okay, while I'm doing that, maybe you can go ahead and sign yourselves into the section. Okay, so the presentation should be viewable now. Could someone give it a try again and let me know if that didn't work for any reason?
It's good now.
Okay, great. And look like one more person just joined. Jennifer, can you introduce yourself to the group real quick?
Hi, yeah, Jennifer Westerbeck, LaSalle High School Engineering Academy Coordinator.
Okay, awesome.
Thank you.
All right. So I think that's all of us, and I'm guessing the link worked now.
Yes.
Okay, great. So I'm going to switch over to presentation mode, and oh, okay, good. Someone already started recording for me. So here we go. All right. Oh wait, sorry. There's the button. And I'll just mention, please check your mics and go ahead and mute when you're not actively talking. That'll make the sound more clear. All right, so some of these slides, those of you who were here yesterday already saw. I'm going to go through them a little quicker today because I want to get to the new stuff for today, but I want people who are new to see these also. So here's the first slide. I'll just go ahead and skip to the next one. We just did introductions and we did our sign-in. For those of you who are gone yesterday, I just want to tell you quickly why I do these workshops. Basically, I want to encourage other teachers to lean more towards starting to think of themselves as inventors and innovators and digital makers, as opposed to just consumers of digital technology. And I want people to learn more about computer science. As I said yesterday, our district's mission is for students to be college or career ready, and I want students to be ready for some of the best jobs, which involve computer coding. Going to this side, there's a lot more computer science jobs out there than there are applicants to fill them. And a lot of high-paying jobs, even if they're not computer science jobs, involve some form of coding as part of the job because we have so many programmable devices these days. So my goal is that more students will be exposed to coding, so someday if they have a job interview and the interviewer asks them if they can do some coding as part of the job, that they'll say yes because they will have been exposed to it. Locally, our computer science graduates have about a 70% placement rate. Those are jobs waiting for them when they graduate, which is much higher than the national average for other courses of study. So I think I already mentioned this one. Okay. So today I want to help you gain an awareness of a variety of online coding sources. Yesterday we kind of focused on code.org and Tinkercad, but we'll be looking in depth at some other ones today. And then just one other data point that I wanted to contribute was from a research article that I read published by Google on computer science education, which indicated that if a teacher or a parent just tells a student that they would be good at computer science, it increases their chances of going into that field by 200 to 300%. And I'd like to see more of our students take part in that profession because those are high-paying jobs and one avenue to success. I'll just leave this here for you to refer back to. It's about design process, and I think it's a good way of thinking as we do projects and things. Here are some of the resources we'll be exploring, but I'll just keep moving through here. The Raspberry Pi is a cheap educational computer produced in the UK, and I'm not going to go through in as much detail why it's such an awesome device today as I did yesterday, but I do want to mention we're going to spend most of our time today utilizing resources on the Raspberry Pi website that don't require a Raspberry Pi to do them. So they're activities that can be done online. Just a quick shout out to the Raspberry Pi 4 computer. They came out with a newer version in recent months that's much faster. And the previous Raspberry Pi was an actual functional computer for $35. The newer version can be purchased for a bit more money with extra RAM and is more on par with your average desktop computer. Here's just a quick slide of what the Raspberry Pi website looks like. We'll be coming back here. Some of the activities on the Raspberry Pi website use this website called Trinket, and it's an online platform for writing computer programs, and you can program on that site using a number of different languages, including Python, Java. You can do HTML and CSS and create websites and things. So this is really it's a great resource that's out there for learning to program. Microbit's a little programmable device. This is really one of my favorite devices to introduce students to computer science with. They're only about $15 or $16, and a student can just plug one of these into their Chromebook and be up and writing code in just a few minutes using a website called Make Code, sponsored through Microsoft. And so this device has two buttons you can program: a 5x5 LED array that can put messages on the screen. And then internally, it has a bunch of sensors. It has XYZ accelerometers. It has a temperature sensor, light sensor. It has magnetic sensors, and it also has Bluetooth and a two-way radio in each one. So really, quite a resource for the money. And I have a bunch of links here you can come back to further explore this device. CodeHS is a resource that our district had gotten a license for with computer classes online. I don't know for sure that we still have a license this year, but in the past, any teacher using a district email could log in and utilize this resource. It also has a CodeHS Hour of Code that's just open to the public, and we looked at a couple of the resources there yesterday. So that's a fun thing to explore and a place to direct students to. I think most people are aware of Khan Academy. Khan Academy has some computer science materials on it, primarily with regards to the Java programming language and using HTML and CSS for creating websites. And the content's pretty good. It's presented in videos, but then they have little activities to do, and they also link to an online editor, so you can actually try it out and create websites or execute Java code as you're going through the lessons. App Inventor is something that was created by MIT to create phone apps. Unfortunately, it only works on Android devices. There's a number of lessons on the Raspberry Pi website introducing people to App Inventor, and it's a pretty awesome thing to be able to tap into the functionality of one's phone. You can tap into the sensors, utilize things like Google Maps, and write your own apps. A little bit of a learning curve, but if one starts with the tutorials and examples, I think you'll get up and running if that's something you're interested in. Code.org is a site to go to for just hour of code type activities. And yesterday I tried going to the site and I didn't see the list of activities I'd looked at in the past. But let me just look at one of these here. Here's one that I don't think I showed you yesterday. I'm not going to utilize it right now, but I just want to click on the link and show it to you real quick. So here's some of the tutorials using, like Minecraft things, and most of these the person doing the activity is using code to direct the characters through the Minecraft world and accomplish little missions and things. Okay, so back to present mode. I mentioned Tinkercad. It's a 3D rendering software that we experimented a bit with yesterday. It's really a neat resource, especially if you're a math teacher. You can model things in three-dimensional space and explore geometries. It's pretty cool. Also, you can model things and then print them out on a 3D printer if you have access to one. Okay, so this is where we're going to spend most of our time today. Let me just kind of click through and see if I'm missing anything in terms of reviewing from yesterday, and then I'll come back to here. Okay, this is all right. That looks about like where I want to be. So here, I'll just back up. Let me come back and let me just kind of check in. I know I went through things kind of quickly here. So I just want to check in and see, is there anything that I just touched on that anybody wants me to explain in a little more detail? And for those of you who are here yesterday, did I kind of go through yesterday's stuff quickly enough that you weren't bored?
Yes, I think you've covered what was discussed yesterday or shared yesterday.
Okay, but extra fast, right?
Yeah, kinda.
Feel like I sped through it. All right, so moving on to the new stuff that I want to focus on today. Here, I'll go back to sharing. All right, and let me find the slide where I left off. Okay, so this is the Raspberry Pi website, and there's a number of educational activities on this site that are not specifically related to the Raspberry Pi computer itself, which I thought was sort of a generous thing of the Raspberry Pi Foundation to teach people about stuff that wasn't, specifically their thing. I'm going to see if you click on this link, it should take us to the Raspberry Pi website. So here we are at the Raspberry Pi website. It took us to the project page. Let me also help direct you there. If you just go to like a Google bar and you type in Raspberry Pi, the first link, if you're on a Google search at least, is pretty much always the Raspberry Pi Foundation site, which brings us here. And usually the resource I'm using is looking at their projects. But before we start that, let me just point out real quick some of the other things that are here. So under education, they have a newsletter. There's some magazines called Hello World. There's also a magazine about the Raspberry Pi called the Magpie. They have Pi Academies all around the world where they have free classes. Unfortunately, they're canceled at the time. And I think probably most useful is the online learning, which I'll come back and show you again in a minute. But they have online classes that you can take through a platform called FutureLearn. You can use this resource for free. But when you use it for free, you only get 30 days to complete your class, and then the class is closed to you, and you would need to log in with a different email address to see it again. All right, so here we're at the project page. Basically, if I'd been here and I'd clicked on projects, and there's some getting started projects here. How to use your Raspberry Pi, learning to code with Scratch. a few other things here. But also, if you just hit Browse All Projects, there's a way to kind of navigate up here. You can just look at everything that they have, and there's like 9 pages of it. And the difficulty level, varies from pretty easy to fairly sophisticated. So this one, for example, build your own octopi would be a fairly sophisticated activity. What they're doing here is they're taking 8 separate Raspberry Pi computers and networking them together and into sort of a mini supercomputer. But most of the activities are pretty easy. Even like a middle school or elementary school student could probably do them on their own. If you want to sort things out and start with the easier activities, you can select the creator level, and those are ones that are more starter activities. And then looking at software, you can also filter your activities. I want to call your attention to things here where we're looking at things where we don't need hardware, where people could just do this online. And the ones that are easiest to do online would be like App Inventor. That's through the MIT site. We're building apps for a phone, Android only, unfortunately. Blender is another 3-dimensional modeling program. And someone who was here yesterday asked if Tinkercad could do animations, which I don't think it can. I know Blender can do animations, and I don't have a whole lot of experience using Blender, but I know it's a free program. You can create things that you can print on a 3D printer, and it's somewhat more sophisticated in terms of the things you can do on it versus Tinkercad. So that's something to look at. HTML and CSS, basically building websites from scratch as opposed to using like a Google websites or any of the other things where you create a website. This is actually coding it from the ground up. And this takes the user over to the Trinket site and uses that as a platform. Programming in Python. Again, we can program in Python using the Trinket site. There's also some other activities that actually program in Python using the Raspberry Pi to do things in the physical world, which we're not going to do. Scratch is a language invented by MIT. It's a puzzle piece kind of language, and that's one of the things I want us to focus on today because I think it's a good entry point for coding for students, and it's also something we can do without having any equipment. And I want to mention real quick about Scratch. I think when I first saw Scratch, I had sort of a bias against it because it seemed a little bit too I don't know, too kid-like, and my mindset's more at a high school level. But after using the microbit and doing block coding as opposed to text coding on the microbit, I've sort of changed my mind with regards to starting out students, especially using a block coding system, because using block coding, we can still really gain an understanding of the structural intricacies of programming and the basic logic and the way one has to think, the thought process, and avoid some of the technical details of writing a program in C or Java or Python where things like, if you forget a semicolon, the program won't work. Or I've just noticed teaching students to program in a text language at the beginning, they struggle a lot with typos and things, and the teacher spends a lot of time basically proofreading their program instead of helping them think about how to create the program. Sonic Pi is only on the Raspberry Pi computer, I think. It's a program for creating music. I'm not sure what Unity is. Wolfram's kind of like a math language. I haven't used BlockCAD and FreeCAD, but I think those are a little bit more like Trinket. And when you see a resource that says web browser, that probably means it's an online activity that you don't need any equipment for. All right, so let's start by looking at some Scratch resources. And again, I feel like I should. Oh wait, did I lose my? Okay, I see what I did here. I feel like I should stop every once in a while and kind of do a check-in. Everybody okay so far? Any questions? Am I going too fast? I can't see the text box while I'm presenting, so. Everybody good? Are you still out there?
Do you want us to create an account so we can follow along, or should we just look at your screen for now?
I think creating an account would be a great idea on the Scratch site, or you don't need an account on the Raspberry Pi site, but we'll go over the Scratch site in a minute, and yeah, it'll creating an account would be a great idea. Okay, good. Everybody's good. You're talking to me. You ever teach online and you start to wonder if like maybe everybody like, you know, just kind of left to go like watch funny cat videos or something? It's strange teaching without being able to see people. But okay, I'll keep going. You're still there. Okay, so it looks like I accidentally clicked on Python here. Oh, I see what happened. I thought I was on the Raspberry Pi site, but actually I was in my presentation. Okay, there we go. So I'm gonna click on Scratch, and there's a lot of and we're here in the beginning mode. There's a lot of activities here, and yesterday I kind of feel like I spent too much time talking and not enough time having people explore resources. So what I want to do is I want to kind of look at one of these activities and sort of go through it with you, but then I want to encourage you to find an activity that you think looks interesting and then try it on your own. Before we do though, well, you can always, here, let's just click on one. Some of these, if it says web browser, then it's probably purely on the online, but you'll notice some of these, like this one here, it says Raspberry Pi electronic components. So I'm guessing this is one where we don't have.
We can't see your screen.
Oh, sorry, I forgot to turn. Thanks for telling me. This is good practice for me for beginning of the school year. I'll stop making these rookie mistakes.
For all of us.
Yeah. Okay, so here I'll back up a little bit since I didn't show you. So some of these say web browser on them, and that means that it's probably just an online resource. But some of them, you know, if you see like Raspberry Pi here, then you probably actually need a Raspberry Pi to do that. But you know, regardless, feel free to click on it and take a look. One of the things I like about the resources on the Raspberry Pi website is it has this little first page where it says what you'll need, and here it'll say, you know, hardware. You need a Raspberry Pi, you know, for a computer and you know whatever else here. So you'd look at this, and if you don't have a Raspberry Pi computer, then you probably want to skip this activity and do one that you can do online. So here I'm going to do, let's see, I'm going to do the boat race. So on this resource, we're gonna make a game. Player uses a mouse to navigate a boat to an island without bumping into obstacles. Let's look at what you need. You need a computer capable of running Scratch 3, which basically means any Chromebook or computer that we would have. And you can either do this online or offline. So I guess you can download the Scratch editor, but we'll use an online one. I also like it has a what you can learn section on all the activities. We're going to use to learn operations to compare numbers in Scratch. Add code to detect when a sprite, that just means the little animated graphic, is touching a different color. I like how this is English spelling. And we're going to use variables to record time in Scratch. And then also a nice thing is for educators, they have a printed version. So if you're doing an activity and you just want to make a printout of the entire activity to look at, as opposed to flipping through page by page on the computer, they have a downloadable resource here for you. All right, so we're going to go to online, and either you can click on here, Raspberry Pi Learning Online. Let me see if I can find. I'm going to click through here. Here's a site about App Inventor tutorials. Here's a site on Scratch, and here's a link to the Scratch website from the presentation page and the boat race activity. but you can also get to it by taking yourself to the Raspberry Pi site, go to projects, and then go to Scratch. So I'm going to have you navigate your way to the Scratch website on your own right now. And let's take a moment when you get there. Let's take a moment and create an account for yourself. So go ahead and sign in with your school address. They ask a few more questions than most websites when we create an account, like how old you are and stuff like that. But it only takes a couple minutes. So I'm gonna wait a couple minutes while you do that. Maybe I'll switch back to the standard mode so I can kind of see, and you can let me know when you're ready. Okay, so everybody's everybody finding their way okay to the Scratch website?
So we're supposed to be in data camp, right?
Data camp.
That makes sense. Welcome to data camp.
That's probably it. Let me share my screen again, and we'll see if we're in the same place.
Okay.
It should look about like this.
Yeah, I think I've been taken somewhere else.
Here,
Yeah, that's okay. Let me try this out because yeah, I think I got sent somewhere else by my fun computer. So so I'll go ahead because I can see Scratch, join Scratch. So yeah, I was in the wrong place.
no problem.
Thank you.
I was going crazy this morning. My mouse was malfunctioning, and it was I don't know. I guess the left click button, it just clicks automatically on its own when I'm not touching it. I got a new mouse, but I kept trying to edit documents, and crazy things are happening. And even though you've gone probably to the Scratch website on your own, I'm gonna have you still go to the Raspberry Pi website and go to the boat activity, because when we go to the Scratch website through the activity, we can click on the version of the project, and that'll put us into the boat activity. But we still want you to have an account, because that way you can save the work you do. Here, and I'm going to put the boat race activity link into the chat bar as well. Okay, there's a link to the boat race activity, so you don't have to sift through and find it, on the website. Okay, account created, account created. Okay, so I can see a couple people have their accounts created. Thanks for letting me know. Once you've done that, go ahead and click on this link taking you straight to the boat activity, and then we'll all be on the same page. All right, does anybody need more time before I start moving on? We have someone new here. Oh no, it's because you show up. I'm still not used to that. When you're presenting, you show up as a second person. Okay, got it. Good, created. Okay, I think we're all there. If you need more time, send me a message in the chat real quick, and I'll know to wait for you. All right, I'm not seeing anything, and hopefully everybody clicked on that link, and we're all at this page. Here, I got to go back and see. Yes, got it. All right, I'm gonna keep going. I hope I'm not leaving anybody behind. Again, this is something I'm not used to, because usually in a class setting I'd walk around and I'd look at what everybody's doing and see that everybody's caught up and at the same place. Okay, so I think we're ready. We're all at the boat race activity. I'm going to kind of go through and let's kind of do this one together. You can kind of click on things and it'll take you over to Scratch, and we can kind of work through this activity together. And then what I'd like us to do today is have you pick an activity to work on your own, and then we can come back together and share what we did. All right, so I'm gonna kind of read through as I do this and sort of pretend I'm doing this for the first time. In this resource, you're gonna learn how to make a racing game. The players use the mouse to navigate a boat to an island without bumping into obstacles. What you will make. And so here's the little boat race, and here we went to Scratch Online. So we already did that. That's this tab over here, and I'm gonna click Get Started. Open the online starter project. So that's what I did. I clicked on that already, and that took me here. And I'll click back and forth as I go. And the project includes a boat sprite. That's a little animated character that's going to move around, and a race course backdrop with wood that the boat sprite has to avoid, a desert island that the boat sprite has to reach. I'm going to click controlling the boat. Next step. The player will control the boat sprite with the mouse. Add code to the boat sprite so that it starts in the bottom left-hand corner, pointing up, and then follows the mouse pointer. Okay, and so here's the code that we're going to create. And if I don't remember exactly what this looks like, I might have to flip back and forth. Someday I'm going to have to become advanced enough to know how to split my screen effectively. But that's okay. All right, so in this language, like a lot of block languages, there's a palette of programming instructions, and keep in mind a program's just a list of instructions that the computer executes. And so some of those instructions make it move. Also, within this format, I can, before I could click on somewhere and move, yeah, I could click on the boat and kind of move it around and place it somewhere. Okay, so these are instructions to move the boat or change its position. These are some instructions for saying things or changing the looks of stuff. There's sound instructions, and then there's events. And the first block in our code is basically a start when clicked event. So there's a start when clicked event. And after that, the first thing we did was we pointed the vote in a certain direction. So here's a point in direction. And I believe in the code we were given, that was 0. So you can just type that in, or it looks like this will let you move it using that dial. And so right now it's pointed to the right. If I click that that top part, that runs the code. In which case, all it does right now is it turns the boat and it points it in direction 0, which is straight up and down. If you're running code and you want it to stop, you click this stop button, but it's not doing much so far. And then the second thing it did was I think it moved 10. Here, I'll go back and look. So next we're going to go to a start position, which is -190, -150. So go to this position. We're going to make x -190. And y is -150. And so if I were to like drag this boat somewhere else and hit the little start button here, it sets it in that direction, which it was already pointing in, and then it drags it to the position on the screen -190, -150. Okay, let's see what to do next. And then after it does those two things, the code's going to drop into forever loop. So the stuff under the when clicked flag only happens once. It only sets the direction and sets the position at the very beginning of the program. And the stuff in the forever loop happens over and over again. And so we're going to point towards the mouse pointer and move one step in a forever loop. So I'm going to come back and do that. And I'm looking for a yellow block that says forever. Okay, here's a forever block. And I need to click it together here. And then, what did that mouse block look like? I gotta go back and look. Point towards mouse pointer, that's one of the blue blocks. Point towards mouse pointer. And the next one I think was said move 1. So this one says move 10 steps. We'll go ahead and, that sounds like a speedboat speed. We're gonna go to slow boat speed, move 1. And I think that's all the code here. Test your code by clicking on the green flag and move the mouse. Does the boat spirit move towards the mouse pointer? And so now we'll do that. Click here, and then now look at the boat. Always wants to go towards my pointer, and I can drive it. Nothing happens when it hits the walls here, which is something we're gonna do next. And then also notice if it actually gets to the pointer, it just kind of goes crazy. So that's going to be like the first thing we're gonna fix and modify in our program. And again, if I don't want this to keep driving around, I can hit the stop button. And I think this is a good point for me to come back and do a check for understanding and see where everybody's at. So, all right. So hi again. I don't know if you need a little bit of time to drag and place blocks on your own. Why don't if you haven't finished, finish that up, and we'll wait for you. And then share your screen. I want to see your boats go. Anyone there yet?
Yeah, I'm there. I'm working on it.
Okay. I feel like this is going to be my school year, staring into a blank computer screen. Are you there? Class, don't leave me.
Can you show your screen again so I can see which pieces you put in?
You bet. But keep in mind also, if you're here, I'll share first. So I'm going to share my screen on the Scratch website, but I also want to call your attention to the activity we're doing from the Raspberry Pi website. And on the first page, they have right here. These are the this is the code that you're going to be creating to start with, because I want to train everybody to be self-reliant and be able to do this on their own. But then also here it is on the Scratch website with my actual code. And while I'm here, I want to see what it's like to be a speedster. So just for fun, I'm going to try changing that to 10 steps and see if my hypothesis about it. So now I'm going much faster. All right. I'm going to go back to 1 for now, though, just so people don't say I'm getting out of control. Okay, so did people who wanted to see my screen hopefully got to see it? I kind of want to go back to stop sharing because I want to see your screens so that so you can share with me and show me what you're doing. Hopefully, did I leave that up for long enough for you to see it, Robert?
Oh yeah, looks
Okay.
like, yeah. I took a screenshot. So.
Okay, I can go back. If you weren't ready. But
No, that's fine.
again, I'm going out of presentation mode so that all of you can share your screens as you get it. Anybody having trouble with how to drag the blocks out or click them together?
Oh, there's one thing. I noticed that the events and the control are almost the same color. So when you're looking around for certain things, it makes sure you just check each one of them.
Oh, right, because one's an orange and
one's light orange. Yeah,
light
so
orange, right?
at least on my screen.
One spirit click events, and then control. Yeah, good point. I'm almost tempted to tell everybody to leave their mics unmuted so I can hear them typing and I know they're working that way.
I can show you my screen if it helps.
Yeah, please do.
There we go.
More
Yeah, it feels
fun.
kind of. Gave a presentation a couple of weeks ago. It just feels weird just sitting and looking into your screen. Let's
I know.
see. Can you see it?
Not yet.
Oh, okay, wait a minute. Maybe I'm sharing the wrong thing.
Well, also,
Oh, there we go. I didn't click. Okay, I have to click on it then. Okay, here we go.
right. The thing I used to forget was clicking on the. You have to click on the little window and get the blue line around it. All right, nice. You're a good driver. Well, you were a good driver.
Yeah, I modified it so I don't have to worry about these walls here. So.
Well, one of our future goals is to worry about the walls. We're gonna have our boat explode when it hits the walls.
Let me speed it up. That's kind of.
At 10, I couldn't even quite drive it. Yeah, see?
Let's see. Let me stop it. Stop.
All right, so I know you're caught up and ready to move on to the next step. Everybody else, you wanna show us what you're doing, and if you're having trouble with any of it, I can help.
Let me unshare my screen.
Okay.
There you go. Okay.
Hey, I heard that dog yesterday.
Oh, let me turn off my mic.
No, it's okay. I like dogs. Like I said, I kind of like having your mic on because then I don't feel like, could be I'm just sitting all alone. I don't know. Anybody else out there to the same point?
Oops. Where was that?
Okay, good. Jennifer's got her boat moving to her mouse. I guess maybe I should ask: is anybody not caught up to this point? Not ready to move on? Salvador got his working. Yay! Mine's working and parked on the sand. You made it, Maria. You're a superstar. Okay, who does that? Who's that leave? Jonathan, did you get yours working? How about you, Josh? How's it going? Okay, Josh is good. Okay, I'll go ahead and move on. I think if you're not caught up and you want help, just let us know. Jonathan's okay. All right. So let's do the next part of the activity. Okay, so I'm going back to my back to the Raspberry Pi page where I'm going to read directions and just kind of work through this. So testing your code, we clicked on the green flag and we drove our boat through, as in this little video.
So you can change it back so we can see what
Yeah,
you're
can you
doing.
present your screen?
See, I'm still a rookie at this. My goal is to be 100% by August 5th. Are we still starting on August 5th? Does anybody know? Because it sounded like when I listened to the school board meeting,
August 10th is the new date.
August 10th is the new date. Did they say why or anything?
No, but the calendar is updated now on the district website.
Okay, I had checked it like yesterday and it was still August 5th, so I wasn't sure if I'd heard correctly. I was glad to hear in the meeting that I don't know if other people submitted their input when requested, but when requested, I pointed out that in my classroom at least, having 50% of the students there would not come close to them being socially distanced, and I recommended that if and when we do go back to a hybrid model, that it be a 25% model at least at first, and it seemed like they had they'd come to that same realization. So, other board news. Okay, back to work. Okay, so let's look at directions. I'm trying to be thorough and just kind of follow through. So so they're saying our next task is to stop the boat from freaking out when it hits the cursor. So to stop this from happening, we're going to use an if block. and to your code so that the boat sprite only moves if it's more than 5 pixels away from the mouse pointer. And we can either look at the we can look here at the code and kind of try to figure out how to do that. But there's also this hint section, which is pretty nice. So I'm going to click on it just to show you that. So they're saying we're going to use an if statement, and if the distance to the mouse pointer is greater than 5 pixels. And they gave it the color coding is also a hint, so we know that the distance to mount pointer should probably be a blue block, and the greater than is a green block. So let's see if we can find that. So I'm going to look for an if statement first. So here's an if-then statement, which is a pretty common thing in computer programming. It's called a conditional statement. And in our forever loop, we're only going to have the boat go if a certain condition's true. Notice if you click on the green area, you can kind of scroll down. So we're gonna use a comparator, and we're also gonna look for something about being within a certain distance from the mouse pointer. Here, I'm going to go back and look at that. So if distance to mouse pointer is, okay. So I'm looking for a distance to mouse pointer. Maybe sensing instead of motion. Touching. Sorry, I'm being a little, oh, here it is. Distance to mouse pointer. Okay, so if distance to mouse pointer, I need a different operator block. We want the distance to mouse pointer to be more than 5, and I accidentally grabbed a less than block. So here, I'll pull this one out. Sometimes it's kind of tricky to get things to click into place. On my screen, hopefully you can see where we got the little highlighted circle around the circle, and then I know it's in the correct place. And instead of 50, I just click on the block and I'll type in the number I want, greater than 5. And then I need to move this into my if-then statement. If you want to get rid of a block, just drag it off to the side and drop it, and it goes away. So now I have a if distance to mouse pointer greater than 5, then point towards the mouse pointer and move 1 step. If this condition's not true, then it's not going to change direction or move. And so now I'm going to click on it. Okay, I'm just going to let it run to the mouse pointer, and then now see how it stopped, and it's not kind of wiggling all over the place and glitching out. So so mission accomplished. It no longer glitches out when it hits the mouse. And that was kind of a short one, but I want to kind of make sure that people are caught up before I move on to the next step.
Hey, the mic got choked up.
I'm sorry, I didn't hear you.
Oh, sorry, I was talking to my family.
Oh, okay.
Come in there. Turn off my mic. Is it?
Okay, I'm gonna go where I can see the screen. Is anybody still working on getting caught up to the point where I left off? Give me a shout out if you need me to pause a little longer.
I'm still working on it.
Okay. We can wait for you. No huge hurry. Robert's still working too. Just activate your mic and tell me tell me if you want help with, you know, finding where the blocks are or anything like that. I keep going back to see if there's any new messages in the chat. And then I'll also mention on the need a hint page, if you click on the little arrow after they gave you the hint, they give you a more explicit hint. So they're actually showing pictures of the block. And if you keep needing more hints, then here they've shown the completed code. So so they make it pretty easy if you're having trouble. I like that about the Raspberry Pi site. Okay, Steven's working on it. Joshua's good.
I'm just having a hard time finding distance 2.
Okay,
I'm looking through the blues. I'm not seeing it there.
Part of it is there's 2 blues. It's can you see my screen now?
Yes.
Okay, so it's the light blue under sensing, and
Right.
I had a little trouble finding it also, and
Okay.
and it's this one right here, the 4th block down.
Okay. Distance 2.
That's the one.
It's not popping into place.
You're trying to put it into the green block.
Okay. That's maybe what I'm doing wrong. Let me go back to look at yours.
Okay, yeah. So after you get that, if
Green.
you can still see my screen,
Yeah.
the green block with pointy ends to it,
Right. Greater than
and you want
50.
to pick the greater than one,
Right.
and then we put it into that block.
Okay, got it.
And change the number from 50 to 5. And as you put it into that block, sometimes it's hard to get it to go in, but you'll see a little white line around the circle when it's close enough that it'll plop in. So that's what it would look like when it's done. Let's see, how are you doing, Maria?
Good. I'm working on making a duplicate now for the boat. That's when it's hit.
Oh, you're way ahead.
So can I see your code again?
Yes. There you go. Can you see it?
Yes.
Here, I'll throw these away now.
What does it mean when it gets a yellow box around it?
It might. Can you show me your screen? It might mean that it's detected an error. But let me see what you're seeing.
Okay.
Oh, I probably need to stop presenting first. Okay. There we go.
Okay, so then I haven't done this before. Present now.
Yeah, hit present now.
And then go to this.
Like full screen, and then you'll have to click on the picture at your kind of upper leftish that shows a picture of the screen. Once you click on it, a blue line will go around that box, and then you'll be ready to share.
Okay, so I see what you're saying. Oh, I don't know. Maybe I don't.
Here, I'm going to do it to make sure I'm explaining it right. So first, I hit the present now button.
Yeah, I did that.
Then I hit entire screen, and
Of what I
then
want to share.
and then what I used to do is I'd hit the share button and wonder why it didn't work. But instead, what I have to do is I have to click on that picture of the screen, and when I do, a little blue line goes around it, and then I can hit share and it'll work.
Okay. So if I can see, when I go back, I can see what I'm trying to share, but no, I'm not getting it. I'm sorry.
That's okay. Let's do it again because
Yeah, like I can see it right now, and now I'm back to you again.
all right, let's try again because you're gonna need to do this soon. So
Okay.
this is actually more important than anything else we're doing. So
Okay, thank you.
so I'm hitting the present now button.
Okay, so I can't see what you're doing.
Okay, that's why I just have to explain it. So present now is the button at the bottom of the screen. You know where that one is.
Right. Yes,
And
I've got that.
And then a window opens, and there's three choices: your entire screen, a window, or a Chrome tab.
Cool.
I always
got
just hit
that.
entire screen.
Okay.
And then another window opens
Mm-hmm.
that says share your entire screen. And it shows a picture of a screen, and at the
Right.
bottom there's two buttons, one that says share, one that says cancel.
Right.
To make it work, you have to click on that picture of the entire screen with your mouse.
Okay.
And when you do, a blue box will appear around the screen.
Got it.
And then you can hit the share button after that.
Got it.
All right,
Okay.
sharing
All
now.
right. Yay. Good.
And now I can go to here.
Perfect. And I'm going to change my setting. This is something I used to have trouble with because someone would share their screen with me, and then it'd be too small for me to really see it very well. And so so I recently learned that I can hit the little three dots with the more options and click on the full screen. And if I want to, even close out the chat box with the X, and now your screen's full sized. I think that yellow outline is just how it displays your code. So everything looks good to me. The only thing is, I think you want to change the green box. Right now it's a less than 5.
Oh.
So you want to change it to be a greater than 5, because right now it would only move if it was kind of right on your mouse, and that's when we want it to stop.
Right. Oh, okay, now I've forgotten. Oh, I see. So I want to take and put this inside here.
Yes.
And then I want this to be on top.
Yep, right there. I can see it highlighted. So yeah, drop it. And now change the 50 to a 5.
There you go.
Yeah,
all right.
But you might want to change the 50 to a 5, or it'll stop. It'll stop. When it's still pretty far away from the mouse.
Cool. Got it.
Okay.
Thank you.
No
Appreciate
problem.
it. Stop sharing.
Okay.
Yay. Thank you
Yay.
for that. That was good. Thank you for that.
No problem. So everybody's Oh wait, are we? Okay, so everybody's caught up to the same point. I'm guessing. And all right, so I'm going to go ahead and move on to the next part. So I'll share my screen again.
Yay.
Okay. So I'm going to hit. Oh wait, I like having captions on. Did everybody else notice that the captions option? I didn't notice that until today. As they're talking, there was text at the bottom of what they were saying, and I thought that was awesome.
Yeah, it'd be really good for ESL students. If they can't hear you, they can read it. So
yeah. So presenting again. So we finished that step. Test your code. Checked whether problems worked. Okay, so we're going to go on to crashing, and I bet Maria's already got a crashing boat done, but I'll step through and do this with you step by step. By the way, if anybody's going super fast and and has already like completed the whole activity, yeah, I'd encourage you to go back to the website and pick a different scratch activity and try doing one on your own. Okay, so at the moment, the boat sprite can simply sail through wooden barriers. We're going to fix that now. So we need 2 costumes for your boat, 1 normal costume and 1 for when the boat crashes. Duplicate the boat spirit costume and name the costume normal and the other one hit. Click on the hit costume and use the select tool to grab pieces. Rotate them to make the boat look like it's crashed into pieces. So that's what we'll do right now. So we're going to, I'm going to go back to the screen. You'll notice there's a tab here at the top. We're on the code one. We're going to go to the costume one. And I'm going to make a copy of my initial boat. Here, actually, I'm gonna right click on the boat itself and hit duplicate. Okay, so there's my normal boat, and here's the second one called Normal 2. I'm gonna rename it Hit because if it hit the wall. And now this is the boat that I'm going to try to break apart. So here I'll try to select a section, and rotate it. Yeah, there we go. Here I'll create another little section, and I actually enlarged it accidentally. Here I'll rotate this one a little bit, create breaks in my boat. I got to bring out my inner artist here, and then maybe looks like there's a brush tool here, paint tool. I want to set my boat on fire, so I'm gonna scribble some red in here. Maybe some orange flames. Can you tell I'm an art teacher? It's okay. 2D art's actually not my specialty, so. We had to make a boat out of clay, I'd be doing much better. Okay, maybe a little more red. I think I'm almost done. Okay, that's my boat explosion, and I'm gonna do here. I want some like little fragments of boat out in the water. All right, we're good. There's my boat. It looks better when it's smaller. Okay, so I'm gonna come back to code, and I'm gonna look at the directions again. So hit costume, grab pieces of costume, move and rotate them to make the boat look like it's crashed into pieces. Nailed it. Now add code to your boat so that it crashes and breaks up when it touches any brown wooden barriers. And then let's look at the hint. So you need a code block inside your forever loop so that the code keeps checking if the boat spirit has crashed. And if it has crashed, the code needs to reset the boat spirit position. If the boat is touching brown color, you need to switch the hit costumes. Say no for 2 seconds, and then switch back to the normal costume. Finally, you'll need to point up and go to the start position. Okay, and I could look at the blocks and kind of sleuth my way through that, or I could also kind of cheat a little bit and look at the code. And so just to speed things up, I'll do that. So I'm going to find a if color touching block. Then do these things right here. And here again, I'll cheat even more. And here's the final code. So run back again. I'll go to events. Okay, if
Can you tell me how you got the brown? Do I have to match it exactly with brown?
you
With
know,
that color brown?
Yeah, and so that's kind of tricky, right? Because
There's a
we haven't-
button you can click on to get the exact pixel color on the,
yeah, the
the
droplet.
option.
Ah.
So if color is touching, if touching color, and then when I, as was just mentioned, when you come here, there's a droplet tool at the bottom, and then you focus that droplet tool on the color you want and click, and that puts in the exact color you want. Okay, and then I'll look back again. So then switch costume, say no, switch costume. So looks, switch costume to hit. There's a say hello for 2 seconds. But if we just click on the hello, we can say no for 2 seconds. And then after that, we're going to basically reset it, I think, right? So then we're gonna switch costume back and then go back to the starting point. So we'll switch costume again, and you'll see there's a little downward pointing arrow right next to hit, and that gives us other options. So we can go to normal, and now we're going to point to direction 0 again and go back to the start. If you right click on a block, you can duplicate it. Oh, it duplicates the whole thing. Okay, never mind. I'll just go up and get a point in direction. Here's a point in direction block. We'll change it to 0. And we also want a move block. Wait, move. Here we go. Go to. And our starting point was -190 and -150. So after we run this, when it starts over, here, now test my code. No, and it goes back to the start. I'm surprised it reset the boat for me. I thought I had to put that in there. Oh, I switched the costume back in the code here. I already did it. Okay. So now it's all working. So I can hit start. My boat drives. If I hit a wall, it explodes. And then the game restarts itself.
Excuse me. How do you switch the hit normal to hit? I'm sorry.
Okay, can you see my mouse right now?
Mm-hmm.
There's this little downward facing arrow next to where it says hit. And if you
Uh-huh.
click on that, then you can select normal.
Well, I click on the down arrow. It's only normal. I
Did
don't know.
you, there's not two options there?
No.
Did you create the extra picture of the boat for yourself?
Oh, wait. Extra
So
picture.
over here under costumes,
Uh-huh.
there it starts with the normal costume,
Okay, you have to create one.
and to make the hit or the blown up boat, what we had to do is first we right clicked on that and we hit duplicate,
Okay.
and then we got a second version of the normal one, and I renamed that version hit, and then I
Okay.
used the editor here to do a little drawing and make it my exploded boat.
Okay.
Uh-huh.
Thank you.
No problem.
Can you show me how to match the brown again? I was on a different
Yeah.
window when you showed me that, so let me blow
Yep.
this up. So
No,
okay.
no problem. You can see my screen now?
Yeah, now I can see it.
Okay, so on the touch color command,
Uh-huh.
if I click on it, I have options to change the colors,
Mm-hmm.
but I also have an option down here.
Aha, okay.
So
There it is. Okay.
dropper, and then I click on the color I want, and it sets to that color.
Okay, great. Yeah, that's what I was looking for.
Yeah, I actually tried this activity last night, and I got stuck on that same point, and then I just had to ask myself. I thought, what would my daughter do? And then the answer became clear, because she's my resident genius.
Yeah, same here.
Yeah, she's been smarter than me ever since she was 2.
No, my daughter's doing JavaScripting already, and she's 15.
Nice.
I always come to her for help.
Yeah, that's why we have kids.
Play a sound.
Okay, you're working your way up to exploding sounds now, right? Anybody or I think probably some people are still working on getting their boat to explode. If you're already to this point, just for fun, how about changing the move steps to a bigger number, like say a 5, and then see if you can see if you can navigate the course on high speed. All right. Let's see. I'm going to stop presenting for a minute. And hey, Maria, you want to show us yours? I want to see your boat explode.
Sure thing. I was going to try to add some sound effects to see if it would make that when it would crash, but I'll share it now.
I made a glug 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 noise when mine crashed, and my daughter said it was annoying. I had to turn it off.
All right.
How long have you worked at Washington?
For 4 years.
4 years?
Yeah.
So my kids went to Washington.
Oh, nice. Yeah, I've only been there since I've started teaching. So teaching 4 years and only been at Washington since I started.
And you've been at a middle school for 4 years. When I was a young teacher, I taught at a middle school for a semester, and then I had to take 4 years off to recuperate.
Oh. All right, let's see. So that's what it looks like when it crashes.
Nice. So what do you think, Maria? Would middle school students would they dig it? Would they like this?
Oh, the kids would love this. I've been hosting like a math club / gamer club at lunch, and the kids are always looking for something to do, whether it's like a puzzle game or something to do with computer coding. I also teach advanced math, and so I always try to think of other projects and try to embed more computer coding with them. So these are great tools for them to definitely be using, especially if we're going to be doing distance learning. This is great,
Right.
great resources for them.
Yeah, the doing things in Scratch I think will be nice, and we're just scratching the surface here.
Yeah, definitely.
Yeah, so there's a lot more you can do with Scratch, and there's tutorials and things on the website. Have I mentioned the microbit really quickly. Do you know what those are at all? Or
I've heard of them, yes, but I think I did one of your workshops a couple of years ago, and I kind of messed around with one of them with like it was like lighting up or setting up the timer or something like that.
oh, nice. I like those because they're fairly inexpensive. You know, so if you happen to have like a chunk of money, you know, budget money from somewhere, they're cheap enough that you could potentially send students home with microbits, and they could do activities at home with them.
Nice. Yeah, next week I'm going to be doing, I applied through code.org for their PD, and I'll be doing that with them next week.
Cool.
Yeah.
Yeah, super fun. Were you a math major?
Yes, I went to Cal Poly, and my husband is also, actually my husband's from Salinas. He went to Salinas High. I don't know if you ever had him, Andrew Parker.
Andrew Parker.
Graduated in 2011. But he was in, yeah.
2011?
Yes.
Trying to think. Like 20 something years from now, I'll wonder if the names start to blur together for you too.
Yeah.
I'd have to see a picture, I bet. I was teaching there in 2011.
Okay.
So ask him if he took ceramics, and if he did, then I had him as a student.
Nice. Yeah, no, he was a physics teacher, but now he's a robotics engineer. So I've gotten more curious with more of the projects he's been working on through his company. So I figured it'd be good to start bringing that into the classroom as well.
Yeah, that's awesome. I was a physics teacher before I became a ceramics teacher.
Oh, nice.
Yeah, so that's why I used to do robot clubs and stuff with students, and so that's kind of my connection to coding with people.
Cool.
My experience back then. So what kind of robotic stuff does he do?
He works for a company called Fetch Robotics, and they're robots that are used mostly for warehouses. And he's on the QA team. So that's what he's working with, and they use Python. That's all I know. Yeah.
Well, I have a if he ever wants one more project that he wants to help a teacher with, I'm trying to find someone with a greater level of expertise than my own, because this friend of mine, he has like this dream that he's had for like a long time, and we've never quite made it actualized his dream, which is he's all into guitar and stuff, and he wants to automate the knobs on a guitar amp.
Yeah, he's a musician as well, so I think he might actually be able to help with that.
Oh yeah, well, send him my email and see if he'll talk to me, because I need advice. I'm trying to help my friend out.
Nice. Yeah, I'm sure he'll be able to reach out to you.
Yeah, cool. Okay, let me check in with other people. Is anybody not ready for me to move on to the next step? Some of you may have already gotten there.
Can you show your screen again so I can see where we are?
Yes. Okay, so this is where we're at right now, and so basically when this goes, and I turned up the speed, it basically just it explodes and says no and starts over when it crashes. I figured out the trick to driving fast, and that is to just let it catch up to the mouse. Okay, so I'm gonna go back to the instructions. We finished this part. Test your code. Okay, so winning. So now we're going to add an if statement to your boat sprite so that the player wins when they make their boat arrive at the yellow island. When the boat gets to the island, the game should say yeah, and then it should end. So so we can create another if then. We'll do a color compare again, but let's speed things up here and go ahead and take advantage of their hints. So, and I'll actually look at the code just to make things go faster. So if touching yellow, then say yeah for 2 seconds and I'll stop. And don't forget that this new code needs to be inside the forever loop. So here I'll go back to my code and I'm going to hit stop here because that's distracting. I'm going to find an if statement. Okay. And I'll put it, doesn't really matter if it's the top or the bottom of the code, I guess. I'll put it down here at the bottom inside the forever loop. I just want to make sure I don't nest it inside one of the other if loops. Okay, so if, and then go to operators. Oh, wait. Sorry. If color touching. So that's under sensors. Wait, no. I forgot where it was. If touching mouse. Okay, if touching color. And again, I'm going to use my little dropper. I'm going to move it up the screen because it went off the edge. I'll use my little dropper again. Select my color. Okay, so, and then I'm going to say, yay. I think I'll say you win. Okay, say you win. 2 seconds. And then it looked like there's a, probably under control, there's like a stop or an end. Let me look back at it. Stop all block. Orange. Okay, there it is. Stop all. So it'll end the game when we get there. So I'll go ahead and try that code. I'm going to slow down my speed a little bit too. To 2. I wonder why it didn't. My boat's still blowing up. I'm a bad driver. Okay, there we go. Okay, I'm racing for the end. It's pretty exciting. Can you believe we're all getting paid for this? Isn't this great? I tell everyone they should become teachers. All right, hopefully it's going to say you win. Yes. All right. I think there's one more thing to do. I think that was to add a timer. Is it okay if I go on to the next step? Sound effects and timer. I'm going to go on the next step, but just unmute your mic and just be like, no, if you want me to come back. Okay, challenge sound effects and adding a timer. So you can add sound effects that play when the boat crashes or reaches the island. You could add background music. There's sound effects in this library apparently that we could download. And then adding a timer. Oh, okay. Sound effects. What looks good here? Okay, I'm going to go look for some sound effects. Mine says pop. I wonder how to find those other sounds.
You click on the volume button, that circle on the bottom, it'll open up other options.
Down
Bottom left.
here?
Yeah, choose down. Mm-hmm.
Okay. Choose sound. Did you find a good crashing sound? I don't want it just to play some music. Alert, boing, clang. Crunch would be a good sound.
Yeah, that's the one I used.
Okay, crunch, crunch. That sounds pretty good. And then back to code. I'll look at sound. Play sound crunch. Okay, and where's the part where I collided? If touching this, we're going to switch to hit. Okay, right there. Say no. I'm going to go crunch. 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 All right, and now I'll go ahead and hit go. I feel like I only got one crunch and I should have got 3. Maybe that's just 3 crunches playing really fast next to each other.
Yeah, I think you have 3 crunches there.
That's 3 crunches. It's not quite satisfying, but I won't fret about it too much for now. I wonder if let me check my other sounds and see if I can play sound until done, crunch, stop sounds, change volume. All right, I'll live with it and keep going here. I want to add the timer next. Okay, add a timer. Now add a timer to the game so that the player has to get to the island as quickly as possible. Add a new variable called timer to your stage. Add a variable to Scratch. Click on variables in the code tab, then click on make a variable. Type in the name you want the variable. Choose whether you'd like your variable to be available to all sprites or to only this sprite. Click OK. So new variable name, speed. For all sprites, click OK. Once you've created a variable, it will display on the stage. You can uptick the variable in the script tab to hide it. Okay, so I'm going to try creating a variable. There's variables. Make a variable. I'm going to call mine timer instead of speed. I have different ideas about what speed is. I hit OK. And so I'm guessing I haven't done anything in my code to change that timer. So here I'm driving around. I don't know why didn't reset my. Okay, there we go. So my timer's not changing. So I'll need to do some coding to make my timer increment. And I'll look at the directions on that. Okay, you can also choose timer. Now add code blocks to your stage so that the timer counts up until your boat reaches the island. And I'll go ahead and look at the hints. But we're going to, on the green flag, we're going to set the timer to 0, and inside the forever loop, we're going to wait 0.1 seconds, and then we're going to change the time by 0.1. Let me see if I can do that without looking at the blocks. So I'm going to set timer to 0 when I first start. And then in the forever loop, I'm going to change the timer by 0.1. So instead of 1, I have to put a decimal point and then 1. And what was the other instruction? Oh, wait 0.1 seconds and then change it to 0.1. I know I was missing a step. So I'm going to wait 0.1 seconds. What color is the wait code? Here, I'll look back. Wait should be light orange. Okay, here's our wait. I'll make it 0.1. And then also, remember that unsatisfying crunch sound? I'm going to change these to maybe 0.3 seconds. I'll see if I can get my crunch sound to not sound all like one crunch by putting some weights in between it. All right, so I'm going to try going again here. Okay, and so notice the wait timer. Our timer's working, but it's slowing down the boat because there's the latency from the timer. Okay, there I got my crunches separated, so I'm pretty happy about that. I'm gonna change my move up to maybe 6. Okay, so now I'm moving at a better pace now. And then crunch, crunch, crunch. All right, I'm happy. And let's see, was that it? So we could start to add obstacles and things in our path. I don't know if these are sharks or what, but we could add other things that we interact with, and again, we're going to compare to that color, I bet, and have it do something based on that. So now the game starts too easy. We're gonna, in fact, we could probably animate our obstacles and make them move around if we wanted to. So we need to add some things to make it more interesting. First, we'll add some boosters to speed up the boat. Edit your stage backdrop by adding some white booster arrows. And now add more code blocks to your boat's forever loop. If touching color of the boosters, then the boat sprite moves 3 extra steps. Okay, let's try. That's not costumes. Under background. Okay, so I haven't done this yet, but under backgrounds there's a paint option. I feel like I just erased everything. Oh.
I think it might be on the next tab.
Over here?
Maybe.
No, that was.
Never mind.
Was that one? But good guess. Can anyone help me out here? This is a good time for a no.
Yeah, I did that a couple of about half an hour ago. Maybe go back. Of course, that might make it Yeah, that might make it worse. I don't know.
I tried hitting the back button and that didn't get me back to it.
Oh.
Maybe V?
Oh, there it is. Yeah, that's the boat's behavior, and then the background's behavior. It's a
So
lot easier that way.
I'm doing great now. I'm not hitting anything. Okay. I'm just wondering if I can reclaim my game here. Did I hit the surprise button to do this? Upload backdrop. Everybody let this be a lesson to you.
Yeah, you can find the backdrop so that you're not all is lost. Oh, there it is. Choose a backdrop. There you go.
But is there
And
a back? I mean,
you're gonna have to find. Yeah, this happened to me. I can't remember exactly what happened, but I got totally lost, and then I clicked back on my sprite, and then everything came back to normal. Let me see. Backdrop.
I clicked on my sprite.
Stage. Backdrops 2.
It's an odd thing. But we basically got pretty much through the whole activity before I blew mine up.
What's the name of that backdrop? Let me see.
I don't know that it was one of the named ones. I bet you can create a backdrop also.
Backdrops 2.
Here, I'm gonna look at the directions and see if they have you just erased your whole backdrop direction. Okay, enter the stage backdrop by adding some white arrows. They didn't explain very well how to draw the arrows in there. Make sure that the color of the gates, okay. Okay, well, sometimes you gotta know when to let things go.
If I can send you a link, you can. I'll give you another backdrop, the same one. I don't know how to send a link on this.
That's okay. I don't mind if my game got erased. I'd kind of later I'll have to figure out what I did so I don't do it again. But no biggie. Let's take a look at the end of the directions. I won't be able to do it on mine, but I think we pretty much went through the whole activity. Proving your game. So some other challenge activities are the only thing left. You could make this a 2-player game, I bet, somehow. You could add more obstacles. So someone put in some sharks and things, slime. Turn your game into a 2-player game, maybe. And you could create extra levels by adding a different backdrop. And can you then allow players to choose between levels? I wonder if I'm wondering if I somehow added an extra blank backdrop. Okay, I bet that's it. I bet this is a blank, and maybe here, no. Sorry. Yeah. Okay. At any rate, here I'll go stop presenting. Did anybody else? They finished it up. They want to share their creation.
Mine's pretty much finished, but I couldn't get it to do anything when I hit the sand. So I mean, I think I made a mistake with that part.
On
You want me to share the
Sure. On that
share
one,
the
you
screen?
can do another color compare.
Yeah.
Like,
Well, I think I missed something somewhere. Let me share my
so
screen.
my guess will be your if then statement for hitting the sand might
Mhm.
be nestled in another if then statement. So it's like not finding it because it's doing something else.
Let's try. Let me just
Yeah,
show
show me
you.
your code and I'll help look at it with you. Here, I got to make your code bigger so I can see it. I got to go to full screen. Oh no, I don't want to change layout.
Can you see it?
Yeah, I just have to make
Oh,
it
okay.
bigger.
Mine says that I'm sharing with everyone, but I can't see it. So.
Right. I don't see your code right now on the screen.
Oh yeah, let me click on the boat. Something was wrong here.
Okay, it's what I thought. Your if touching yellow statement,
Mm-hmm.
that's nested inside of a separate loop.
Oh, so it has to go down here. Okay.
Yeah, but grab it by the if, not by the touching color.
By this one?
Yeah. Pull that down, and then you still want it in the forever loop, but you want it on top of that bottom notch, I think.
Ah, okay. Oh,
Yeah,
and I have a quick question.
right there.
Is there any way to export this code to where it looks like normal code, and to keep working on it as a different type of like a JavaScript or whatever coded or Python, whatever it comes out as? Or is it you do all of the editing in the
as not that I know of.
Oh, okay.
Yeah, I don't know of a way to like convert to another kind of code. I do know that with the microbit, you can program in block code called Java blocks, and then they have a button where you click, and it converts it over
nice.
to JavaScript. So you can kind of go between the two different kinds of code.
Yeah, it'd be fun to do this the easy way, and then if you want to add some things that aren't available, you can just get in and make some modifications.
Yeah, it's also a nice way to start learning a different kind of language. You can set it up the easy way and then see what it looks like.
Yeah.
And we can do that in the Java blocks. Tomorrow's workshop, I'll do Java blocks, and we'll use the microbit simulator. And for some people, I got a microbit to them in the mail, so they'll be able to actually plug it in.
All right, cool. Yeah, I have one.
Nice. So
I bought it at Fry's because it was like $5, and I never did anything with it. So.
Got it for $5?
Yeah, it was on sale at Fry's.
Wow, I wish I knew about that. I would have bought it.
It was like old, like the box was all faded and everything. But yeah, it still works. I played with it after last year. You had a presentation on my microbits, and I started playing with it after that. It still works. So.
That's the deal. They're usually about $15, $16.
Yeah, it works, but it just doesn't say you win at the end. I don't know why.
Well, I'm curious if it doesn't. Huh. I don't know why you're not getting your message.
Oh, well.
It, though.
Yeah. That's fine.
It's a mystery. We'd have to experiment around a bit to get it.
Okay, let me
all right.
Yeah, so let me fix that.
Okay, I'll go back to presentation mode and see. So I'm glad we kind of like worked through an activity where everybody worked on it instead of just me going through it. It took longer than I anticipated, but everything in my life is kind of like that. So, so not enough time for you to probably like pick an activity on your own and work through it. But I would encourage you to do that just for fun. You know, go back to the Scratch website, or go look at the Raspberry Pi website and look at some of the other activities that they have with Scratch, and try them out. Also, I just want to call your attention to some of the other activities on the Raspberry Pi website. There's some on Python, and so I thought the turtle race one was pretty good, so I put a link to it here. There's also Turtly Amazing, which is it draws like spirograph pictures using code and little turtles that leave a colored trail behind them. So I think that's a fun one also. And again, there's the HTML CSS activities on the Raspberry Pi website can be done without actually having a Raspberry Pi. And then last thing is here's a little workshop session evaluation link. So if you could please go ahead and fill out the evaluation link. And here I'll stop sharing again and go back to camera mode. Anybody else want to share their, what they did on Scratch before we do the evaluation and wrap things up?
I guess I can share mine.
Cool.
Can we have the link again for the evaluation?
Yeah. Here I'll copy it and put it in the chat bar.
Oh, there we go.
And then for the sound, I added a scream. So if it hits the side, it does a little scream.
You're right.
I got a timer, but it doesn't really have any purpose to it.
Is it not keeping time?
I mean, it's keeping... Oh, is that the only point of it? There was no special trick? Because it is keeping time.
Yeah, right now it just keeps time, so you can try to speed up and see if you can beat your previous time.
I didn't know if it was supposed to be like a countdown, like you had only a certain amount of time to do it.
It's not programmed to be like that right now, but that'd be a fun challenge. You could probably change it to do that.
And then, all right.
And then it can screen if you don't make it there by a given amount of time. So what do you think, already? Did you have fun playing with Scratch?
Yeah, it's a great resource. It's fun.
Nice. I haven't really used much Scratch. I haven't used Scratch much before, but I liked it too. But last night was my first time using Scratch. Well, thanks for coming, everybody. Yeah, please go ahead and fill out the eval for the peeps. And anybody have any final thoughts or questions before we wrap it up?
Thank you. I really like this. I'm still figuring out the sounds, but I'll find a way to put them together. When I compared yours and the one that was presented, it was something different. So I'm gonna try to figure it out.
Yeah, and I noticed on my crunch sound that all sounded like one crunch. I had to put some wait statements in between them, so it went crunch instead of just crunch.
Thank you.
Yeah, thank you. It's been fun.
So William,
Yeah.
it's Jennifer.
Uh-huh.
Do we know what? Am I going to go to district office? Am I coming to you?
I guess you're coming to me because I haven't heard back from the person who would be dropping it off there. Wait, I don't have email on my phone. I'll check my email real quick before.
Okay.
just in case. Oh wait, okay. I do have an email from the person that lives closer to you. Let me see what she said real quick. Okay, wait. I'm just opening email. So, Jennifer. Okay, she sent an email to you also. It looks like. So Jennifer,
Okay.
you can meet me to pick up the microbit stuff for Bill Thompson's session. I can meet you halfway, or can leave it on my front porch and you can grab it. And she lives in Marina. So
Okay.
closer than coming here. And that'll also save me a little bit of time because the stuff I bagged up for her, a microbit, but I also put a breadboard and a variety of sensors and a servo motor and, you know, a nice little bag of assorted things to experiment with.
Mm-hmm.
A little piezoelectric speaker.
Perfect. Thank you.
And so she'll have a bag with all the stuff.
Well,
Something cool I did with the microbit and the piezoelectric speaker was I put a little sleeve of paper around the little miniature speaker, and you know how when you play a musical instrument, the sound resonates in the instrument and makes it
yeah,
loud.
right.
Well, it turns out that a sound wave has nodes and antinodes. The nodes are the low amplitude points, and the antinodes are the high amplitude points. And it turns out for a stringed instrument, it likes to resonate such that the string likes to resonate such that there's nodes at the endpoints. And on an air instrument, it likes to resonate such that if there's a closed end, there's a node on the closed end, but an open end, there's an antinode located there. So, so for a tube, the shortest section of a wavelength that'll fit in the tube is a quarter wavelength with a node at the closed end and the first antinode at the open end. So that's the fundamental frequency. A quarter wavelength will resonate in the tube. So I played a tone with the microbit, and then I adjusted my two sleeved tubes until I heard an amplification of the sound. And that's the first fundamental frequency, which is 1/4 wavelength of the sound. And then I measured the length of the tube at that point and multiplied that by the frequency I was emitting with the microbit, and thereby measured the speed of sound. And
Sounds very interesting.
and
Wow.
and the results, you know, a lot of times, you know, I'll do an experiment, and you know, data's tricky sometimes, and the results are not conclusive. But I was pretty reliably getting results within, you know, 1 to 5% of the actual speed of sound. So it was a pretty reliable way to measure the speed of sound with a microbit and a cheap little 50-cent speaker.
Sounds very interesting.
Yeah, so I'll have to do a video about that experiment. That was a fun one.
And I have a ton of speakers at school. So,
Yeah,
so yeah.
You'll need to power it directly from a microbit. You'll need to use one of those little piezo speakers,
Yeah.
as opposed to
Yeah.
like an actual speaker.
Right.
To use an actual speaker, you'll need probably a separate voltage source, and you'll need a power transistor.
I think I do have the piezo speakers also.
Yeah, nice.
Yeah. With my I have a Bobot.
Oh, from yeah, those have them from Parallax.
Yeah,
Yeah,
from Parallax. Yeah.
Those were what I used. That was my first exposure to robots, was using Bobots. Yeah.
So I still use them.
Uh-huh. They're they're great little robots.
Yeah.
That was basically their design was my inspiration.
Yeah, I recognized it. I did. Okay, well, so I'll go pick that up, and I'll see you for tomorrow's workshop.
Okay, and then we can meet up at a Zoom meeting and talk about like ideas and stuff.
Okay, sounds really good. I've got a lot of stuff to go over, so thank you so much. I appreciate it.
Yeah, my pleasure. Have a great day.
You too. Bye-bye.
Bye.